Evaluate yourself. 1. Given in page number 9. From the lesson Physical and Chemical Equilibrium. Consider the following reaction. Fe3 plus SCN minus both are in aqueous condition to form in equilibrium reaction with Fe SCN whole power 2 plus. Okay. So a solution is made with initial Fe3 plus and SCN minus concentrations are 1 into 10 power minus 3m and 8 into 10 power minus 4m respectively. At equilibrium, Fe SCN the whole 2 plus concentration is 2 into 10 power minus 4m. Calculate the value of equilibrium constant. So first you have to write the Kc value, equilibrium constant Kc for you, this given equation. How to write Kc? The equilibrium constant with respect to concentration, that is denoted by Kc, is equal to concentration of the product divided by concentration of the reactant. Okay, so before that, just you have to write what is the initial concentration and what is the number of moles reacting, then what is the number of moles at equilibrium. Okay, so in the problem it's given number of Fe3 plus at the initial stages 1 into 10 power minus 3 and SCN minus, the anion is having the concentration 8 into 10 power minus 4. At that time product is not formed, so we put a dash here. Then after that, what else is given here means 2 into 10 power minus 4m. Another one concentration is given at equilibrium, right? These are the concentration given in the initial state. This is the concentration at equilibrium. When it reaches the equilibrium, this is the concentration of this complex. Okay, so just you leave this line. After that only you have to calculate that. Then number of moles at equilibrium, this is not given, this is also not given. Only 2 into the Fe SCN the whole 2 plus is given, 1 into 10 power minus 4. Okay, so out of this SCN, this is 1 mole, all are present in 1 mole. 1 mole of Fe2 plus Fe3 plus 1 mole of SCN and 1 mole. Okay, so 2 into 10 power minus 4 is taken for 1 mole of SCN 2 plus, means here also SCN is also 1 mole. So the same amount will be in the number of moles reacted. இவ்வளோ ஃபார்ம் ஆகுதுன்னா உனக்கு எவ்வளவு molecules react ஆயிருக்கும், the same amount is reacting from Fe3 plus and SCN minus. Okay, so number of moles reacted 2 into 10 power minus 4 and SCN minus reacted 2 into 10 power minus 4. It is, this value is not given in the problem, we got it from this value. Okay, then number of moles at equilibrium. Okay, so number of moles at equilibrium, already you have this value, only these two values you have to identify. So initial concentration you know, number of moles or number of moles reacted also you know. Can you calculate the number of moles at equilibrium or remaining number of moles of SCN and Fe3 plus? Just you subtract these two values means you can get. Okay, so 8 into 10 power minus 4 minus 2 into 10 power minus 4 means 6 into 10 power minus 4. Here one value is in initial concentration is 10 power minus 3, just to make it into 10 power minus 4 means multiply with 10 into 10 power minus 4. Then the number of moles reacted already you got 2 into 10 power minus 4, subtract these two values means number of moles at equilibrium 8 into 10 power minus 4. So Kc, how to calculate, how to write the Kc for this equation? Product is FeCN the whole 2 plus. Okay, so Fe concentration of Fe SCN the whole 2 plus divided by Fe2 3 plus concentration into SCN minus concentration. So substitute the values here. For this is for SCN, sorry, Fe SCN the product 2 into 10 power minus 4 divided by number of moles of Fe3 plus is 8 into 10 power minus 4. Number of moles of SCN minus is 6 into 10 power minus 4. Substitute this values means 10 power minus 4, 10 power minus 4 cancel, 2 and 8, 4. So 1 divided by 4 into 6, 24 into 10 power minus 4. So we can write it as 1 divided by 24 means we can get 0.0416 into 10 power. This 10 power minus 4 will go to the numerator means 10 power 4. We can write it 41.6 into 10 power 2 per meter. Sorry, per m. Okay, so this is concentration, so you have to represent mole per liter. Mole per liter is represented by capital N, so 41.6 into 10 power 2 mole per liter, or capital M per minus 1. Evaluate yourself. The same page, page number 9, second problem. The atmospheric oxidation of NO is given in the equation form. 2NO plus O2 gives 2NO2. Was studied with the initial pressure of 1 atm of NO and 1 atm of oxygen. At equilibrium, the partial pressure of oxygen is 0.52 atm, atmospheric pressure. Calculate the Kp of the reaction. Okay, so Kp is asked because partial pressures are given. How to write Kp? Kp is in terms of partial pressure. Okay, so partial pressure of oxygen is given. They have to calculate the Kp at equilibrium condition. So write the given equation. 2NO plus O2 gives 2NO2. Then you label the what are the reactants and product, and what is the initial partial pressure given in the problem. Okay, so NO and O2 are the reactant, NO2 is the product. Okay, so initial partial pressures are given for NO is 1 and O2, oxygen is also 1. At that time, for product it will put the dash. Again, one thing is given at equilibrium, the partial pressure of oxygen is given. It is given in the last line. At equilibrium, partial pressure of oxygen is 0.52 atm. So at equilibrium, so that is in third column. Second column is number of partial pressure, reactant pressure. At the last column, at equilibrium pressure. Okay, so at equilibrium, partial pressure is given for only oxygen, 0.52. Okay, so initial pressure is partial pressure is known. At equilibrium or remaining pressure is also known. Means can you calculate the pressure reacted? Okay, so this value can be calculated by 1 minus 0.52. 1 minus 0.52 means 0.48, right? Okay, so number of partial pressure reacted 0.48, right? Then this is 1 mole, this is also 1 mole. Okay, so here this is one mole. For 1 mole, what is the value you got? Reacting molecule 0.48. Okay, so here also 1 mole is reacting, so 0.48. Then, so how much is remaining here? For NO, how much is remaining in equilibrium condition? 1 minus 0.8 means 0.52, right? Then the last column, come to the last column. Here product is not formed. Here also products are not formed. Here 2 moles of N2. Okay, wait 1 minute. Here number of moles taken is 1. But here 2 moles are reacting. Okay, so 2 moles of NO is reacting. So 2 into 0.48, that means 0.996. Okay, so here NO is having 0.96, O2 is having 0.58. Okay, so here how much is remaining here? It is not 0.52, it is not 0.52. 1 minus 0.6 means 0.04 will be remaining. Okay, 0.04 is remaining. Then for NO, to come to the last column, NO2 only after the equilibrium reaches only it will have the molecule pressure. Okay, so here it is given in the equation 2 moles. For 1 mole 48 means how much is for 2 moles? 2 into 0.48, because 2 moles of NO is formed, NO2 is formed, so 2 into 0.48, because 1 mole na for 0.48. Okay, so here it represents for 2 moles, so 2 into 0.48 means 0.96. Okay, so NO2 formed is 0.96 at equilibrium. Then Kp, what is Kp? This is partial pressure, already you got it from this tabular column. So partial pressure of the product NO2 the whole square, because in this equation number of moles is 2. Okay, so the number of moles are there means you write it as a power. Okay, so NO2 the whole square divided by what is for reactant side NO. So NO concentration, P partial pressure of NO the whole square into P of O2, because oxygen is having only 1 mole. Okay, then substitute the value for NO2. NO2, what is the value? 0.96 the whole square divided by what is NO? This is NO. Okay, NO 0.04 the whole square into 0.52 for oxygen. Just you calculate this value, means you can get Kp is equal to, simplify this value means you can get Kp is equal to 11.07 into 10 power 2 per atmospheric pressure. Okay, so partial pressure, equilibrium constant in terms of partial pressure is equal to 11.07 into 10 power 2. Next, evaluate yourself. Given in page number 12, the following water gas shift reaction is an important industrial process for this production of hydrogen gas. CO plus H2. The equation water gas shift reaction is carbon monoxide plus water gives CO2 plus H2. At a given temperature, Kp's value is given as 2.7. If 0.31 mole of carbon monoxide, 0.56 mole of water and 0.78 mole of carbon dioxide and 0.28 mole of hydrogen are introduced into 2-liter flask, and find out which direction must the reaction proceed to reach the equilibrium. What is asked in the question? To reach the equilibrium, in which direction the reactant proceeds. Equilibrium reach பண்ணதுக்கு இவ்வளோத்தையும் நம்ம எடுத்துட்டோம்னா equilibrium reach பண்ண reaction எந்த directionல போகும், forward or backward. Okay, so already we know that from this Q value and Kc value we know that how to predict the direction of the reaction. Okay, so first you write the given data. Kp is given 2.7. Then carbon monoxide concentration is 0.31, carbon dioxide is 0.78, water 0.56 and hydrogen 0.28, and volume is also given 2 liter. You know the relation between Kp and Kc. Kp is equal to Kc into RT power delta Ng. Here substitute the values. Instead of Kp you have to substitute 2.7 is equal to Kc is unknown value into RT power you have to calculate for delta Ng, because delta Ng for this water shift gas reaction, this is the reaction. What is the number of product? What is delta Ng? Delta Ng is equal to Np minus Nr, number of moles of product minus number of moles of reactant. In this equation, how many number of products formed? 1 plus 1, 2. Number of moles of reactant side, 1 plus 1, 2. Okay, so 2 minus 2, 0. Delta Ng is equal to 0 means anything power 0 is equal to 1. So Kc is equal to 2.7. So Kc you calculated as 2.7. Then before it reaches the equilibrium, that is denoted by equilibrium constant, or it is denoted by Q. Equilibrium reach ஆகிறதுக்கு முன்னாடி உள்ள initial concentration நம்ம substitute பண்ணனும், we can get the Q value. Then you compare Kc and Q value, you can get the direction of the reaction. Okay, so Q is equal to what are in the product? This is similar to Kc, equilibrium Kc, equilibrium constant Kc. So carbon dioxide and H2 concentration divided by CO into water concentration. Then all the concentrations are given in the problem. Then substitute here, because here carbon dioxide 0.78 divided by 2. How will you get divided by 2? This is number of moles present in 2 liter. This much concentration present in 2 liter. Okay, so 0.78 divided this much gram amount divided present in 1 liter will give the concentration, because concentration is equal to N by C, number of moles by volume. Number of moles is 0.78 moles of carbon dioxide present in 2 liter. Okay, so we will get all the terms, the concentration terms when calculated divided by 2, all the given amount. Okay, so if you substitute here, all the simplify this value means you can get 3. So Q value 3 and Kc value 2.7, which is greater, 3 or 2.7? 3 is greater, so Q is greater than Kc, hence the reaction is proceed in reverse direction. Q is greater than Kc means Q is greater means reaction proceed in reverse reaction. So reaction is proceeding. For this, to reach the equilibrium, the reaction is proceed in reverse direction. Next problem, evaluate yourself for, given in page number 15. 1 mole of PCl5 kept in a closed container of volume 1 decimeter cube and was allowed to attain equilibrium at 423 Kelvin. Calculate the equilibrium composition of the reaction mixture. Kc value for PCl5 or dissociation at 423 Kelvin is given as 2. Okay, so Kc value is given. You have to calculate the equilibrium composition of the reaction mixture. Okay, so what is the required equation? PCl5 is kept in the vessel. Okay, so container, we want 1 decimeter cube container. So PCl5 undergoing dissociation to form PCl3 plus Cl2. Already know this equation. Then PCl5 concentration is given 1 mole and volume of the container is 1 decimeter cube. Then Kc value is also given. Just to draw the tabular column, the tablet, the reactants and products. Okay. Initial number of moles for PCl5 taken in the container is 1. At that time, products are not formed. You put 0 or dash. Number of moles reacted. From that, X moles are reacting. Okay, so just we do not know that. So just we consider that X moles of reacting here, or that time also product not formed. The number of moles at equilibrium is equal to 1 minus X, but initial minus reactant will give the number of moles at equilibrium. So PCl5 constant at equilibrium is equal to 1 minus X. Then at that same time X moles of PCl3 and X moles of Cl2 is formed. Then equilibrium concentration is equal to, what is the volume given? 1 decimeter cube. Okay, so number of moles divided by volume. So this equation we can, this formula, this term you can get it from N by V, number of moles by volume. Volume is already is given 1 decimeter cube. Okay, so 1 minus X divided by 1, X by 1 and X by 1. Then what is Kc value? Kc value for this above equation, for this equation, how can you write for Kc? Kc is equal to concentration of the product, PCl3 into Cl2 concentration divided by PCl5 concentration. Okay, so this is the Kc formula. Then substitute all the values. Kc value is given in the problem 2. So 2 is equal to, what is PCl3 concentration? X by 1 into X by 1. Cl2 is also having X by 1 divided by 1 minus X by 1. X by 1. Okay, so divided by 1, no value. So we can cross multiply, means 2 into, cross multiply this. 2 into 1 minus X is equal to X into X, X square. So 2 minus 2X, multiply this inside the bracket. 2 minus 2X is equal to X square. So X square is equal plus 2X. Just you write it in the exponential form of X power. So X square plus 2X minus 2 is equal to 0. This is in the quadratic equation. This is like a quadratic equation. So what is the quadratic equation formula? X is equal to minus B plus or minus root of B square minus 4AC divided by 2A. Then here just you take A is equal to 1, right? A is equal to 1. Then what is B value? B is equal to 2. This is B. Then for C, minus 2. Then substitute the values in that equation, quadratic equation. Substitute here, X is equal to, instead of B you have to substitute minus 2. 2 plus or minus root of B minus. Okay, so 4 minus, wait. So substitute here, this is the equation, minus B plus or minus B square minus 4AC divided by 2A. So instead of B you have to substitute 2, then B square 4 minus 4 into A, then this is also multiply into C. C is also minus 4. Okay, so then 2 into A is equal to 1. Then you simplify this, means you can get minus 2 plus or minus root 12 divided by 2. So plus or minus minus 2 plus or minus root 12 can be written as 4 into 3 divided by 2. So 4 into minus 4 into 3 inside the root can be written as 2 into root 3. So we can take the two values, minus 2 plus 2 into root 3 by 2 and minus 2 minus of 2 into root 3 divided by 2. When you simplify this, means you can get minus 1. This is for minus 1 root 3 value. Negative value is not acceptable. This is positive. Minus 1 means it's not a positive value. The negative value can be neglected. So we can neglect this value. So only you have to take the positive value. Minus 1 plus root 3 is 1.732. So subtract this 2, means you can get 0.732. So X is equal to 732. So what is PCl5 concentration at equilibrium? 1 minus X by 1. Already know from the table. Then instead of X you have to substitute this value. 1 minus 0.732 means what is the value? 0.268. Then PCl3 X by 1. So 0.732 divided by 1. So the same answer. Cl2 is also having the concentration X by 1. So 0.732 divided by 1. So 0.731. So this is the way to calculate the concentration of the reaction mixture. Next, evaluate yourself. Given in page number 20, problem number 5. The equilibrium constant for the following reaction is 0.15. Equilibrium constant means Kc value is given at 290 Kelvin and 1 atmospheric pressure. The equation is N2O gives 2 NO2. Sorry, N2O4. Okay, so here it is one mistake, N2O4, because it's not balanced, only I find out. So N2O4 gives 2 NO2. Delta HF for this value is given 57.32 kilojoule per mole. The reaction conditions are altered as follows. first subdivision, the reaction temperature is altered to 100 degree. Then keeping the pressure at 1 atmospheric pressure, calculate the equilibrium constant. So at 100 degree Celsius and the pressure is keeping at 1 atmospheric pressure, calculate the equilibrium constant. So this reaction, this calculation is based on Van 't Hoff equation. Already you know what is Van 't Hoff equation. Log K2 by K1 is equal to delta H0 by 2.303 R into T2 minus T1 divided by T1 T2, right? Okay, so here two temperatures are given. T1 is 293 because at Kc value is given at 273 Kelvin. So 273 Kelvin, delta HF is given at 298. So that is taken as T1 is equal to 298 Kelvin. Then at what temperature you have to calculate the equilibrium constant? Calculate the equilibrium constant at 100 degree. Okay, so 100 degrees Celsius means converted to Kelvin. Kelvin just you have to add 273, right? So 100 plus 273, 373. Then Kp value is also given 0.15. So Kp1 is given. You have to calculate Kp2 at 100 degree. So this is the Van 't Hoff equation. Log of K2 divided by K1. K2 divided by K1 is equal to delta H0 divided by 2.303 R into T2 minus T1 divided by T1 T2. Here K2 is greater than K1 and T2 is also greater than T1. T2 is always greater than T1. Otherwise, we can get the negative value. So log of Kp2 divided by this one you have to calculate. K1 is given. Kp1 is given 0.15 is equal to, just you substitute this value. Delta H value is given 57.32, right? 32, not 2, 32. Okay. So 57.32 divided by 2.303 into R value is already studied what are the three R values. Here you have to kilojoules per mole, so it is R value is 8.314 into 373 minus 298 divided by 373 into 298. Just you multiply, subtract this 2 means 75, so write that value. This kilojoules converted into joules, you have to multiply by 10 power 3, subtraction, it will get 75. Then you write the below numbers, what else given here. Then log of Kp2 divided by 0.15 is equal to this value. If you simplify this means you can get 2.02. So log of Kp2 divided by this is 2.02. Okay, just you take this. To remove this log, just you take this log to opposite side means it will go that side means anti-log, right? Okay, so what is the next step? In between one step I missed here. So Kp2 by Kp 0.01 is equal to anti-log of 2.02. Okay, so anti-log of 0.02 will give 4.7. So now we can able to calculate Kp2. Just to cross multiply these two values. Okay, so Kp2 is equal to 104.7 into 0.15, that will give Kp2 is equal to 15.705. So this is the value at Kp2 value at equilibrium constant value at 100 degrees Celsius. Next book back problem given in page number 27, question number 40. 1 mole of PCl5 is heated in 1 liter closed container. If 0.6 mole of chlorine is found at equilibrium, calculate the value of equilibrium constant. Here also what is asked? Kc is asked. So PCl5 equilibrium is we have to calculate. 1 mole of PCl5 is heated in 1 liter closed container. Okay, so concentration is equal to N by V. Number of moles is 1 divided by volume is 1 decimeter cube. So 1 by 1. Then Cl2 concentration is already given 0.6 mole. Okay, so 0.6 divided by 1 also we can get 0.6. Then what is the required equation for this problem? PCl5 on decomposition to give PCl3 plus Cl2. Then what is PCl3? Cl2 is 0.06 means already because all are in 1 mole. Okay, so Cl2 formed as 0.6 means surely PCl3 is also formed in the manner 0.6. Cl2 ஏன்னா PCl5 dissociate ஆகி உனக்கு PCl3 and Cl2 கிடைக்குது. Cl2 1 mole and PCl3 is also 1 mole. அப்போ இது 0.6 இருக்குதுன்னா இது கண்டிப்பாக என்னதான் இருக்கும் 0.6 mole per decimeter cube. Then PCl5 எவ்வளோ இருக்கும்? PCl5 that is at equilibrium means 1 mole its initial At equilibrium, just we are this much is reacting. Okay, so how much is remaining? 1 minus 0.6 is 0.4 mole per decimeter cube. Then you have to calculate Kc. After that only you have to calculate the equilibrium constant. Kc is equal to PCl3 concentration is Cl2 concentration divided by PCl5. Substitute the values. PCl3.6, Cl2.6 divided by PCl5.4. Just to simplify this means you can get 0.9. Kc value 0.9. Question number 41. For this following reaction, strontium carbonate SrCO3 gives strontium oxide plus carbon dioxide. The value of, just you notice here in this equation, the reactant, one of the reactant is solid form, and this is also in solid form, right? The value of equilibrium constant Kp is given at 1002 Kelvin. Calculate Kc. So they are asked to calculate Kc value. So by using the Kp Kc relation we can calculate, right? So first you have to find out what is delta Ng. Delta Ng 1 minus 0. How it's 1 minus 0? Because when we are taking delta Ng, this G represents only for gaseous molecule. Okay, so what is this gaseous molecule here? Only carbon dioxide. Okay, so that is also in reactant side. So reactant concentration 1 minus number of moles of product 1 minus, here in the reactant side only one reactant is there, and that is also in solid form. So we that is kept as a constant. Number of moles is not changing throughout the reaction. இது வந்து என்ன செய்யாது, சாலிட் எடுத்துருக்கிறது எப்போவுமே சேஞ்ச் ஆகாது. நம்பர் ஆஃப் மோல்ஸ் கேஷஸ் மாலிகுல் எடுத்துருக்கிறது மட்டும் சேஞ்ச் ஆகும். ஸோ ஃபார் calculating delta Ng only we have to take the gaseous molecules. Okay, so 1 minus 0 1. Then substitute Kp is equal to Kc into Rg power 1. Then so the same value Kc into Rt. Then substitute the Kp value 2.2 into 10 power minus 4, that is given. Only they asked to calculate Kc. Kc is the unknown value. Okay, then R value is 0. Kelvin scale 0.0821 into temperature is also given 1002 Kelvin. Then just to take this Kc right left hand side means what is the calculation? 2.2 into 10 power minus 4 divided by 0.0821 into 1002. Simplify this means you can get 2.647 into 10 power minus 6. So Kc value is equal to 2.674 into 10 power minus 6. Next question number 42. To study the decomposition of HI, the student fills a student fills an evacuated 3 liter flask with 0.3 mole of HI gas and allow the reaction to proceed at 500 degree Kelvin. At equilibrium, he found that concentration of HI is 0.05 m. Calculate Kp and Kc. So what is given? Volume is given 3 liter. HI concentration, number of moles is given 0.3 divided by 3 liter means 0.1. Then same way we have to calculate the concentration of HI. HI is equal to HI concentration is only given because HI is this is not correct. Up to this one, HI concentration is 0.3 divided by 3, so number of moles is 1.1. Then you take this column, right column, HI, H2, I2, based on the same reaction, because HI is on decomposition, we can get the product H2 and I2. Initial 0.1 is taken. Then how much is formed is here 0.5 moles. HI formed is 0.05. So in the problem it's given hydrogen iodide formed at equilibrium is 0.05. This is for initial concentration. Okay, its initial concentration is 0.1. Then at equilibrium the concentration is found to be 0.01. The student found that 0.01 m. Okay, so just you write 0. Equilibrium. Without writing this, just you write 0.05 as a result you are getting at equilibrium. So can you calculate the how much is reacting? 0.1 minus 0.5 means that is the remaining. So that much is reacted, 0.05. Then here H2 plus H2 gives, what is the equation? H2 gives HI gives H2 plus I2. Okay, 2 moles of HI decomposed to form H2 plus I2. So this is for 2 moles. The 2 moles na 0.05 na 1 na evlo irukum, half of that value. This is for 2 hydrogen iodide. 2 hydrogen iodide hydrogen iodide 0.05 இருக்கு. இதில் H2 இருக்கு. 2H இருக்கிறதுனால for one H2 means H and H are there. So for one hydrogen, what is that value? Adila padi, half of that value, 0.025. Then I2 is also having 0.025. Then you substitute this value in this Kc is equal to H2 into I2 divided by Hi the whole square. Substitute the values of 0.025 into 0.025 divided by 0.05 the whole square is equal to 0. Simplify this means you can get 0.25. So how to calculate Kp? Kp is equal to Kc into RT power delta Ng. Delta Ng is equal to 0. So RT power 0. RT power 0 is equal to 1. So Kp is equal to 0.25. So that is the answer for this question number 42. Next problem, question number 44 given in page number 27. 1 mole of methane, CH4 is methane, and 1 mole of carbon disulfide and 2 mole of hydrogen sulfide and 2 mole of hydrogen are mixed in a 500 ml flask. The equilibrium constant of the reaction, that is Kc, 4 into 10 power minus 2 whole square per liter square. In which direction will the reaction proceed to reach equilibrium? The same before one problem we did like this. Just you have to calculate Kc value is given, you have to calculate Q value, then comparing Q and Kc value we can identify to which direction the reaction proceeds. Okay, so the required reaction is CH4 plus H2 is combined to form carbon disulfide plus water. Just to balance the equation, Kc value is given in the problem 4 into 10 power minus 2, volume is also given 500, that means half liter. So what is the concentration of CH4? CH4 1 mole is taken, already it's given here, 1 mole of CS2 and 1 mole 2 mole of H2S. Okay, so 2 mole of H2S and 1 mole and 4 moles are taken. Okay, so just to calculate the concentration term, methane is having 1 mole, so number of, this is based on N by C is equal to N by V. Okay, so what is number of moles? 1 mole divided by volume is half liter. Then CS2, what is CS2? Number of moles is 1 divided by half liter, therefore 2 mole. Here also it will go to the numerator, the 1 divided by 1 by 2, 2 will go to numerator means 2 mole per liter. Then H2S, 2 mole divided by 1 by 2 because 2 moles of H2S. Okay, 2 divided by 1 by 2, this 2 will go to the numerator means 2 into 2, 4 moles. Then for H2, 2 moles are there, so 2 divided by half liter, so this 2 will go in the numerator means 4 moles per liter. Then what is how to calculate Q value? CS2 into, because the reactant product side CS2 and product side, what are the products from here? CS2 and H2 the whole power 4 divided by CH4 and H2S the whole square. Substitute the values, 2 into 4 power 4 divided by 2 into 4 square. So we can get 60, that is Q value. What is Q value given? The Q value already got 60. What is Kc value given? Kc is equal to 4. Kc is equal to 4 into 10 power minus 2. Here it is 16. Which is greater value? With that numerical value you can know that Q is greater the value. So when Q is greater the value, the reaction proceeds in reverse direction. Okay, so backward reaction is possible. Question number 45. At a particular temperature, Kc value is given as 4 into 10 power minus 2 for the reaction. H2S gives H2 plus half S2. That is the reaction that is considered to be first. Equation number 1. Calculate the Kc for each of the following reactions. So the first subdivision given is 2H2S gives 2H2 plus S2. So first equation already given. Just to multiply this first equation into 2. First equation, just you multiply with 2 means what is the resultant equation idu kuda, and the first equation kuda 2 vachu appadiye throughout the equation multiplied by 2 because it's a multiple of 2. Okay, இது அப்படியே மல்டிப்ளை பண்ணால் உனக்கு இந்த மல்டிபிள் டூ மல்டிபிளில் வரும். ஓகே, ஸோ H2S into 2, so 2H2S gives this also into 2, so 2H2, this also into 2 means 2 into 2 and cancel, so S2. So that equation is similar to the given equation, first subdivision. Okay, so அப்போ என்ன பண்ணும்? Kc value for that equation is, first equation is 4 into 10 power minus 2. So this equation, the given equation is twice of that equation. Okay, so Kc is also multiplied by 2 means we can get 4 into 8 into 10 power minus 2. Then second subdivision, 3H2S gives 3H2 plus 3 by 2S. The same first equation should be multiplied by 3. 3 which you multiply pannu, just you multiply this 3. Then here also with 3, here also with 3. So what will be the resultant equation? 3H2S. Just you look at this. 3H2S gives 3H2 plus 3 by 2 S2. So that is similar to the first equation, but it's a multiple of 3. Okay, so the Kc value for this equation, first equation, it is 4 into 10 power minus 2. So this is in multiple of 3 means that Kc value is also multiplied by 3 means 3 into 4 into 10 power minus 2, 12 into 10 power minus 2. Question number 46, 28 gram of nitrogen and 6 gram of hydrogen were mixed in a 1 liter closed container at equilibrium. 17 gram of ammonia was produced at equilibrium. The end of the reaction, 17 gram of ammonia was produced. Calculate the weight of nitrogen and hydrogen at equilibrium. What is the question? As weight of hydrogen and nitrogen we have to calculate. Okay, so what is the given data? Mass of nitrogen 28. So here 28 gram of nitrogen is taken and 6 gram of hydrogen. Okay, so mass of nitrogen is 28, mass of hydrogen is 6. Okay, so volume of the container is 1 liter. So from this mass value with the volume, mass value which can we calculate the number of moles? Number of moles is equal to given mass divided by molar mass. Molar mass of nitrogen is 1 for 1 nitrogen 14 into 28. Okay, so given mass is 28. Mass of nitrogen divided by molar mass. This is done by the equation, the formula given mass divided by molar mass. This is the given mass. Okay, so given mass divided by molar mass, 28 divided by 28. Only given mass is known value. This is already it's a known value for you, because nitrogen is 1 nitrogen is 14 means 2 nitrogens having 28. Okay, so 28 divided by 28, 1 mole. So number of moles of nitrogen 1. So what about the number of moles of hydrogen? 6 moles are taken. So 6 divided by 2. How we can get 2? For 1 hydrogen mass is 1. So for 2 H2 means 2. Okay, so 6 divided by 2, 3 moles. Okay, so the required equation N2 plus 3 H2 gives 3 NH2. So NH3 produced at equilibrium is given as 17 gram. அப்போ இந்த 17 gram produce ஆகுதுன்னா எவ்வளோ மோல் நீ இந்த கிராமில் இருக்குது, பட் we are calculating the value in moles. Okay, so the given the amount of ammonia formed at equilibrium is divided by, this is also for ammonia, mass of ammonia divided by molar mass of ammonia என்ன வரும்? 14 plus 3, 17. So 17 by 17 is equal to 1 mole. Then you tabulate this nitrogen, hydrogen. In this equation, nitrogen, hydrogen and ammonia is the reactants and product. Then initial 1 mole of nitrogen and 3 mole of hydrogen. That time product is not formed. Just you leave the second because unknown value. At that last portion, equilibrium concentration la எத்தனை mole form ஆயிருக்கு? 17 gram means that is 1 mole. Okay, so only this column you know 1 mole of ammonia is formed. Remaining value you can know, because 1 mole means NH3, 1 mole of NH3. Here 1 mole of NH3 na எவ்வளவு? 17 gram of NH3. Okay, so அப்போ அதே மாதிரி 1 mole of N2 நான் அதில் பாதி, இதில் என்ன இருக்குது? N2 இருக்குது. ஸோ 1ல் பாதி தான் ரியாக்ட் ஆகுது. ஸோ வாட் அபவுட் திஸ் வேல்யூ? இந்த 1ல் half மீன்ஸ் 0.5. அப்போ 0.5 உனக்கு ப்ராடக்ட் அட் இக்லிபிரியமில் கிடச்சிதுன்னா ஹவு மச் இஸ் ரியாக்டிங்? 1 மைனஸ் எவ்வளவு கிடச்சா 0. எதை சப்ராக்ட் பண்ண 0.05 வரும்? 1 minus 0.05. Okay, so 1 minus 0.05. So 0.05 is reacting to get 0.05. Then hydrogen is in 3 moles. 3 moles is required in this equation. Above equation 3 moles. அப்போ 3 moles இருக்குது. அப்போ 1 மோலுக்கு பார்ட் வந்து மடங்கு வந்து 1 மோலில் நம்ம எதை எப்படி ரெப்ரசன்ட் பண்ணுறோம்? 0.05ன்னு ரெப்ரசன்ட் பண்ணுறோம். ஸோ 0.5 0.5. Okay, so 0.5 now one part is 0.5 means what about 3 part? 3 into 0.5, so that is 1.5. Okay, so 1.5 அப்போ 3ல 1.5 is reacting means how much is remaining at equilibrium? 1.5. So now we can know all the values. Can we calculate the weight of nitrogen? Weight of nitrogen is equal to number of moles of nitrogen to molar mass of nitrogen. So number of moles of nitrogen is 0.5 into molar mass is 28, so 14 gram. Number of moles of hydrogen is 1.5. Sorry, number of moles of hydrogen is also 0.5. Sorry, not 1.5, 1.5. Okay, so 1.5, it's one mistake here. So here we got, I wrote it with pencil, it's not clear. 1.5, how you got this? One part na 0.5, so 3 part means 1.5. Up 3 la 1.5 react aitna, remaining is 1.5. So for number of moles of hydrogen is equal to 1.5 into molar mass of hydrogen is 2, so 1.5 into 2 means 3 grams. Question number 47, the equilibrium for the dissociation of xy2 is given as 2xy2 gives 2xy plus y2 if the degree of dissociation of x is so small, too small compared to 1. So x is very small when compared to 1, so very small value. Show that 2 kb is equal to P of x3, where P is the total pressure and Kp is the dissociation equilibrium constant for xy2. So the equation given is 2xy2 gives 2xy plus y2. So just you tabulate this, what are the reactants and product, and write down the initial number of moles. Initial number of moles 1. Here products are not formed. From this initial number of moles, how much is reacting dissociated? X moles are reacting. Already they said X moles are reacting is very less than, very so small as compared to 1. Okay, so here also product was not formed. So how much is remaining at equilibrium? Initial 1 and reacting dissociated x. So 1 minus x. X is very small amount, so we can neglect, means that is equal to 1. Here x moles are dissociated means x moles of xy and x by 2, because இது ஒன் பார்ட்னா இதில் பாதி y2, அதுதான் y2 னா அதிலே ரெண்டு பார்ட் இருக்கு, அப்போ x by 2. So y2 formed as x by 2. Okay, so total number of moles is equal to, because we have to calculate the Kp la partial pressure is there, partial pressure ku total number of moles vanu. So total number of moles can be calculated by 1 minus x plus x by 2. We can get 1 plus x by 2. X is very small value, so we can neglect this. The x by 2 means that is also equal to 1. So already you know that pressure is equal to, partial pressure is equal to Kp in terms of partial pressure. Okay, so you know the formula, partial pressure is equal to mole fraction into P. Mole fraction எப்படி calculate பண்ண? Mole fraction is equal to number of moles divided by total number of moles. Okay, so this capital P gives the total pressure, right? Okay, so Kp formula, you know, partial pressure of xy the whole square, because 2xy is given. Okay, then partial pressure of y2 divided by partial pressure of xy2 the whole square. Okay, then substitute for xy, what is the concentration you got it for xy? Just xy can concentration x. Okay, so x divided by total number of moles on the 1 into total pressure. Adhe madri what is for y2 can x by 2. Okay, so x by 2 divided by total number of moles 1 into total pressure divided by xy2 ku 1. So 1 divided by 1 into p the whole square. So xp the whole square, that means x square into p square into x into p divided by 2p square. Okay, this 2 will come here, 2p square. So this p square and p square cancel பண்ணிட்டோம், என்ன வரும்? x cube, x square into x cube into p. So 2, this 2 will taken this side, means just to cross multiply. So 2 kp is equal to p x cube. Next problem, number 48, book back problem. A sealed container was filled with 1 mole of A2, 1 mole of B2 at 800 Kelvin and total pressure 1 bar. Calculate the amount of the components in the mixture at equilibrium given that K is equal to 1 for the reaction. What is the reaction given? A2 plus B2 gives 2AB. So this is the reaction. K value is given, and the temperature and the concentration of A2 and B2 is also given. Just you have to calculate the amount of the components. Calculate the amount of components in the mixture at equilibrium. Okay, so first you have to write the equation. A2 plus B2 gives 2AB. Then you have to tabulate this, the reactants and products. The initial concentration is given as 1 mole and 1 mole. At that time products are not formed, so you put a dash here. Number of moles reacted. From this 1 mole, x moles are reacting. Just we consider that reacting number of moles is x. Okay, so x moles of A2 and x moles of B2 is reacting. Then in product side, product is not formed, so you put a dash here. So number of moles at equilibrium means remaining number of moles after the 6 moles reacted, how much moles are remaining. So 1 minus 6 for A2, B2 also 1 minus 6. At the same time, x plus x here this compare this equation 2AB, so 2x moles are formed as a product. Okay, so one more point we have to calculate, because we have to calculate Kp. So total number of moles can be calculated by sum up of all the number of moles at equilibrium. So 1 minus x plus 1 minus x plus 2x. So 2x and 2x can cancel, then 1 plus 1 2. Okay, so total number of moles 2. Then again we have to calculate the Kp value. Kp is equal to partial pressure of AB the whole square, B of A2, partial pressure of A2 into partial pressure of B2. So how can you calculate partial pressure? Already you know the formula for partial pressure. Partial pressure is equal to mole fraction into total pressure. Mole fraction, this formula you studied in gaseous state. Gaseous state, Dalton's law of partial pressure. From that you know partial pressure is equal to mole fraction into total pressure P. Then again in first lesson before you studied what is mole fraction. Mole fraction of A, you are going to calculate for mole fraction of A means that is denoted by XA. So XA means you have to write number of moles of A divided by number of moles of all the components present in the solution. Okay, so here total pressure is equal to P of A2 plus P of B2 plus P of AB, because these three are taken in this reaction. So P of A2, for example, I'll show how we are going to calculate P of A2. P of A2 is equal to A2 means we have to calculate for mole fraction of A2. So N of A2 divided by what are the reactants and products here? N of A2, number of moles of A2 plus number of moles of B2 and number of moles of A and B into total pressure P. Okay, so like the same way substitute here means what is the number of moles of A2? Number of moles of A2 1 minus 6. Okay. Sorry, number of moles of AB. Number of moles of AB is 2x. So 2x by 2. Total number of moles already calculated as 2, right? Number of moles at equilibrium for AB. AB is 2x because the formula is P of AB, partial pressure of AB. So 2x by 2 into total pressure the whole square divided by partial pressure of A2. This is the partial pressure of A2, 1 minus x by total number of moles 2 into total pressure, and for B2 1 minus x by 2 total pressure, total number of moles into total pressure P. So if we simplify this means you can get 4x square divided by 1 minus x the whole square. Already given that Kp is equal to 1. Okay, so Kp is equal to 1. Substitute Kp is equal to 1 means 4x square divided by 1 minus x the whole square is equal to 1. So I can rewrite this 4x square divided by 1 minus x the whole square is equal to 1. Then cross multiply this, 4x square is equal to 1 minus x the whole square. Then 4x square, this is in the form of a minus b the whole square. Expand this means you can get 1 plus x square minus 2x. A square plus b square minus 2ab. Then you simplify, take all these terms to our left hand side and put is equal to, taken as equal to 0 means we can simplify this. We can get 3x square plus 2x minus 1. This is in the form of quadratic equation. Quadratic equation formula minus b plus or minus root of b square minus 4ac divided by 2a. Here b is equal to 2, c is equal to minus 1, a is equal to 3. Substitute the values here. Minus b, so minus 2 plus or minus root of 4 minus a into 4 into a into c divided by 2a. Then you simplify this means you can get minus 2 plus or minus root of 16 by 6. Okay, so simplify, root of 16 means 4, root of 16 4, so minus 2 plus minus 2, sorry here minus 2, okay, minus 2 two values we can take, minus 2 plus 4 divided by 6 minus 2 minus 4 divided by 6. Okay, so simplify these two terms means you can get minus 2 by 6 and minus 6 by 6. So one is having 0.33 and another is having minus 1. So minus value is not possible, so you only have to take the positive value 0.33. So what is the question asked? Components of concentration of all the components at equilibrium. Okay, so concentration of A2, concentration of B2 and concentration of AB we have to calculate. So first you have to calculate concentration of A2. Concentration of A2 is equal to what is given in the tabular column? 1 minus x. Okay, so x value you got 0.33, so 1 minus 0.33 means 0.67. Then b2 also same value, 1 minus x, so 0.67. What is ab? 2x. Okay, from the tabular column, just you revise it, revise the tabular column. Okay, so ab is equal to 2x, so 2 into 0.33, so answer is 0.66. So these are the concentration of the reactants and products. Problem number 50, the equilibrium constant Kp for the reaction Haber's process. N2 plus 3H2 gives 2NH3. Ammonia synthesis is 8.19 into 10 power 2 at 298 Kelvin and 4.6 into 10 power minus 1 at 498 Kelvin. So, 2 Kp values and 2 temperatures are given. Calculate delta H0 for the reaction. Okay, so Kp and 2 Kp values and with the help of 2 temperature, and delta H is related by 1/2 equation. Okay, so what is 1/2 equation? 1/2 equation, already you know that, log of Kp. What is the last term you derived in log of equation is log of Kp2 divided by Kp1 is equal to delta H0 divided by 2.303 into T2 minus T1 divided by T1 T2. So here Kp1, that is for 298 Kelvin. Temperature is 298 Kelvin. That is considered to be T1. At that time Kp1 is equal to, constant is equal to 8.19 into 10 power minus 2. Then at T2, 498 Kelvin. At that time Kp2 is equal to 4.6 into 10 power minus 1. Substitute these values here. In Kp2, what is that value? 8.12. Okay, so sorry, Kp2 4.6. So 4.6 into 10 power minus 1 divided by Kp1 8.19 into 10 power minus 2 is equal to delta H. So you have to calculate the unknown value divided by 2.303 into, for R value in Kelvin scale, 8.314. Okay, that you had to by heart that value. Then T2, what is T2 value? 498 minus 298 divided by 498 into 298. If you simplify this term means, if you subtract this, you can get 100. Then here you have to multiply these two values. Okay, then just you simplify this whole term, log of this value and this value means we will get minus of 3.2505. Then take this, all this denominator to that side, left hand side, means this log value into 2.303 into 8.314 into 498 into 290 divided by what else is given? 200. 498 minus 290 to delta 200, the difference is 200, is equal to delta H0. Then delta H0 means, simplify this value means we'll get minus of 46,181. Then just it's in joule per mole. Just you convert it to kilojoule. You have to give a point after this 3 decimals. So answer is delta H is equal to minus of 46.18 kilojoules per mole. Next problem number 51. This is the last problem. The partial pressure of carbon dioxide in this reaction CaCO3 on decomposition to form CaO plus CO2, that is partial pressure of carbon dioxide is 1.017 into 10 power minus 3 atmospheric pressure at 500 degree Kelvin. Calculate the Kp at 600 degree for the reaction. So for 500 degrees Celsius Kp is given, you have to calculate Kp at 600. Okay, so 2 temperatures and 2 Kp, 1 Kp is given, 1 Kp they asked to calculate. So this is also by using 1/2 equation. Delta H is also given as 181 kilojoules per mole and does not change the temperature, given range of temperature. So what are the given values? P of CO2, partial pressure of CO2 is 1.017 into 10 power minus 3 at 500 degree Celsius. So just you convert it into Kelvin, to Kelvin scale, just you add 273. Already you know that degree to Kelvin means add 273. Then Kp at 600 means at 873 you have to calculate. Delta H is given 181 kilojoules per mole. Okay. Then Kp is equal to P of CO2. Because how to calculate Kp for this equation? Kp, because these two terms are in solid form. For solid, then concentration does not change throughout the reaction. So the equilibrium is equilibrium constant only depend upon the reactant and product which is in gaseous form alone. Okay, so for writing this equilibrium constant Kc, it will only depend upon the gaseous form of carbon dioxide. Okay, so we can take it as Kp is equal to P of CO2. Otherwise Kc we can write means Kc is equal to concentration of CO2. Only it will depend upon CO2, carbon dioxide term. So the same way we can write it for Kp means Kp is equal to partial pressure of CO2, right? Then take the van der Waals equation, Van 't Hoff equation. Log of Kp2 divided by Kp1 is equal to delta H0 divided by 2.303 by R into T2 minus T1 divided by T1 T2. Then log of Kp2 you have to calculate. So instead of that we have to substitute all the values. Kp1 value delta H is also given. Then 2.303 into R already 8.314. Temperature is also substituted, means you can get 181 into 10 power minus 3 into 100 divided by 2.303 into 8.314 into 873 into 773. Then just you are taking this log, because you suppose you have to take log for this term, means this is an unknown value. Okay, so instead of that you have to take this log to right hand side, means it will convert into anti-log of this simplified value is 1.40. So left hand side what else is given here? Kp2 divided by 1.017 into 10 power minus 3. So if you are taking anti-log for 1.40 you can get 25.12. So Kp2 divided by 1.017 into 10 power minus 3 is equal to 25.12. Therefore Kp2 is equal to, just you cross multiply this to right hand side, means Kp2 is equal to 25.54 into 10 power minus 3. So this is the equilibrium constant Kp for at 600 degree Celsius.